we can consider the switching loss during change of state. At this point, we can consider that there is no leakage current and there is no on-state voltage drop. So in this case, we can only consider the switching loss during change of state. Okay. So now you consider this purple line. This purple line is during this, before this T on start, it has a off state. So off state means there is a finite voltage. V switch is present here and current is 0. Okay. Though there is a small leakage current, but at this moment we can consider there is no leakage current. Okay, so current is 0. So at this point, turn on is started. Okay, so it is not the ideal case. In the ideal case, it is instantaneously going to the reach to the maximum value. But as it is a practical switch, it needs some time to reach its maximum value. So this is the time. So when the switch is from off state to on state, what is the time required to change its state? It's the small t on. You can consider this one. And when the switch is from on state to off state, again you can see that it is not instantaneously going to be 0. It has a slope. Okay. In the slope, it is gradually decreased to 0. So this time when on state to off state, it is called a T off, small t off. It will be denoted as. So during the t on, small t on time period. So this during transition from off state to and on to on state, transition time small t on, I switch equals to capital I by T on into T. So here the I is the current flowing through the switch, T on is the transition time, and this T is the total time taken for the T on and T off. Okay. Similarly, the V switch. As the V switch, you can apply the straight line equation. So it is mx plus c, but here it is the slope is decrease in nature. So c and mx, here t is the function. So v minus v by small t on into t. Similar equation. So switching loss during on-state transition. Power loss, switching power loss during on-state. P switching on equals to V switch into I switch. So at this moment, what will be the switching loss? So you can multiply this V switch into I switch. So I, capital I by T on into small t, and this V minus V by T on into T. So you can just split it like this, Vi small t on into T minus Vi T on square into small t square. So we know that for maximum or minimum value of this power loss, we have to derivative this part, and the derivative part will be equal to 0. So now make those things, dp switch by dt should be equals to 0. So make it derivative form. So Vi by T on will be the common for these two component, and we can just take it a common, and then d dt into t minus t square by t on. So that will be equal to 0. So if you go to the mathematics, it will be coming that the small t should be equal to t on by 2. Okay. So small t is the t on plus t off. So it will be the t on and t off will be the same. Now coming to the what will be the switching loss. So P switching average on state loss we will calculate. So it is 1 by time period, integration of 0 to t on time. Just here we are considering the t on time period, what will be the power loss. So 0 to t on instantaneous power into dt. So 1 by t total time period we have considered t. Here the total time period means on time period and the off time period of the switching operating time. Okay, so 1 by capital T. Instantaneous, so 0 to t on is the integration limit, and you can put this value the previous value of P switching into dt. So take out the common part and what will be the rest is here. So after making the integration part, we have to put the value of the limit 0 to small t on. Okay, so putting this value here, it is coming as Vi by 60 into small t on. Small t on is the time required from off state to on state. In a similar manner, we can calculate the average switching power loss during the t off, small t off timing period. Means when it is from on state to off state. And similarly, it is coming as Vi by 60 into t off. Okay. So now we will get the total average switching power loss by addition of these two. So it is coming as Vi by 60 into t on plus t off. This capital T is the total time period, and this total time period can also be replaced by the frequency. Means 1 by t is can be replaced as f frequency. So VIF by 6 into t on plus t off. Okay, so this is the total switching power loss expression. So that's all for today. Thank you for your attention.